is over writing equations of parallel and perpendicular lines. This is day 1, and we're going to be graphing. We're going to be looking at slope, y-intercept. We're going to be looking at slope-intercept form of a linear equation and standard form of a linear equation today. So let's get started. First, we're looking at slope-intercept form of a linear equation. You may remember this from Algebra 1. It's y equals mx plus b. M represents the slope and B represents the y-intercept. And I've got a vertical line written here because in a coordinate plane, that vertical line is your y-axis. So this value right here, this B value, is your starting point. That's what we're going to graph first. It's your y-intercept. It's where it crosses that y-axis. So there's slope-intercept form of a linear equation. In the left column, we're going to be looking at lines that are parallel to one another. And in the right column, we're going to be looking at lines that are perpendicular to one another. And you may recall in the last lesson where we talked about slopes of parallel and perpendicular lines, the slopes of parallel lines are the same, and the slope of perpendicular lines are opposite reciprocals of one another. So let's look at number 1. It says to graph line M and line K. Line M is y equals 2x minus 5. The first thing I'm going to do is identify my slope, which is 2, and my y-intercept, which is negative 5. I'm going to start at negative 5 on my y-axis, plot a point, and then I'm going to graph it going up 2 over 1, up 2 over 1. And I get this line right here. So y-intercept of negative 5. And then I go up 2 over 1, up 2 over 1, up 2 over 1. Sorry about that. And you can double check yourself, make sure you've graphed it right. This has a positive slope. Is that a line that shows a positive slope? It is. It goes from lower left to upper right, so I know I graphed it correctly. Now let's graph line K. First, let's identify the slope to be 2, and the y-intercept in this case is negative 8. So we already looked at the slopes of parallel lines are the same, and you can see that your slope is that number that's right in front of the x. And when it's written in this form, you can easily see your slope. That is a slope of 2. This also has a slope of 2. I'm going to graph it the same way I graphed line M. I'm going to start at my y-intercept, which is negative 8. I'm going to put a dot there, and then I'm going to rise 2 and run 1. Rise 2 and run 1. And I get line K that looks like that. And now you can visually see these lines are parallel. They have the same slope. Let's look at example number 2. It says to graph lines A and B, and you can already see they have different slopes, and their slopes are opposite reciprocals of one another, right? If that slope is positive 1/2, if I flip it and take the opposite, I get negative 2 over 1, which is just negative 2. We're going to do the same thing with line A. I'm going to identify the slope, which is 1/2, and the y-intercept, which is 2. And then I'm going to graph it using graphing my y-intercept first. That's my starting point. So from my origin, I'm going to go up 2, put a point there, and then I'm going to graph the other points on the line. I'm going to rise 1 and run 2, rise 1 and run 2, and I get this line right here. And I'm going to label it line A. Moving on to line B, I'm going to identify my slope is negative 2, and the y-intercept is negative 4. So the first thing I'm going to do is starting at my origin, I'm going to plot that B value going down to negative 4. Then from there, remember that's a negative slope, and it's negative 2, which is the same thing as negative 2 over 1. So I'm going to go down 2 over 1 to the right, down 2 over 1 to the right. Put a bunch of different points down, and I get this. So starting at negative 4, down 2 over 1, down 2 over 1. And I can put a bunch of points like that. I can see it's a negative slope. I've graphed it correctly. And you can see they intersect at 90 degrees, right? 90-degree angles. Those are perpendicular lines. Let's move on to example number 3. This one, in 3 and 4, we are given lines on the coordinate plane and we're asked to write the linear equations. Well, in this case, I'm going to identify line C, the y-intercept, and the slope. The y-intercept, or the slope, is 1, and the y-intercept is 6. So I know it crosses my y-axis at positive 6, right? Or 0, 6, and it goes up 1 over 1, up 1 over 1, up 1 over 1. Slope is 1, y-intercept is 6. How am I going to write that as a linear equation? Y equals 1x plus 6, which is just x plus 6. Now let's graph line D. Looks like my slope is also 1, and the y-intercept is negative 3. When I write the equation for this, I get y equals 1x minus 3, or y equals x minus 3. Now let's look at example number 4. We're going to write linear equations g and h in slope-intercept form. Let's look at line G. What's the slope and where does it cross the y-axis? If you want, find your m and your b now and see if you can write the equation for this line. My y-intercept is negative 4. It's right there. And my slope is down 1 over 3. Down 1 over 3. That's negative 1 over 3. As a linear equation in slope-intercept form, I write it y equals negative 1/3 x minus 4. Line H, what's the slope and what's the y-intercept? And then what does it look like when I plug that into a linear equation? The slope is positive 3. My y-intercept is positive 5, right? So I can put a bunch of points down and I know I'm going up 3 over 1, up 3 over 1. When I plug in m and b in slope-intercept form, I get y equals 3x plus 5. Now let's move on. Oh, I guess I need to write, I'm sorry, I forgot I did this. This would be good to write down that parallel lines, slopes are the same. Perpendicular lines, slopes are opposite reciprocals of one another. So let's move on to standard form of a linear equation. When I'm given an equation in standard form, which you see this very often, you need to convert it to slope-intercept form and graph. And you don't always have to graph, but you need to be able to convert it to slope-intercept form. What does that mean? That means you need to solve for y. So we're going to do that on each one of these. We're just going to practice solving for y. Let's look at example number 5. I've got line A and line C, and I know these lines are parallel. Okay, so they should have the same slope. But let's solve for y. The first thing I'm going to do is, and I've got all the work shown for you, I'm going to subtract 3x from both sides. So that moves that 3x over, and now I'm left with 4y on the left equals negative 3x plus 12. No, you cannot combine these. They are not like terms. Now, I need to get y all by itself, so now I need to divide by 4. What I do to one side, I have to do to the other side. I can write it like this. The entire thing is divided by 4, but what that means is each term is divided by 4. So negative 3x over 4 looks like this. Negative 3/4 x. Then 12 divided by 4 is positive 3. That's how I would write that in slope-intercept form. Now let's look at line C. We're going to do the same thing for line C. We're going to subtract 3x from both sides. I get 4y equals negative 3x plus 4. And then I'm going to divide everything by 4. Y equals negative 3/4 x plus 1. Negative 3 divided by 4 is just negative 3/4. Then 4 divided by 4 is 1. And you can see these lines have the same slope. Negative 3/4, that's what's in front of the x in this one. Negative 3/4, that's what's in front of the x in this one. This is slope-intercept form. We just converted standard form to slope-intercept form. It's called that because you can see very clearly the slope and then the y-intercept. Let's move on to example number 6. Now these lines are perpendicular, so they already look a little different, okay? We're going to solve for y in this first equation for line M. I do that by subtracting 5x from both sides. I'm left with negative 2y equals negative 5x plus 10. And then now watch what I did here. I'm just writing it differently for those of you that need to see it differently. When I divide by negative 2, notice over here, everything gets divided by that, right? Well, right here, I'm really doing the same thing, but I'm showing you this gets divided by negative 2, and this gets divided by negative 2. So I'm left with y equals, well, negative 5 divided by negative 2 is positive 5 over 2, x. 10 divided by negative 2 is negative 5. Let's look at line N. If you want to pause the video and try on your own, I would suggest doing that. But here's the work. The first thing I'm going to do is subtract 2x from both sides. I'm left with 5y equals negative 2x plus 15. Then I need y all by itself, so I need to divide everything by 5. Y equals negative 2 divided by 5 is just negative 2/5. Then I have the x. 15 divided by 5 is 3. So as you can see in these two lines, in slope-intercept form, this has a slope of 5 over 2. Well, the line that's perpendicular to it is going to have a slope of, flip it and take the opposite, negative 2 over 5. Let's go back over here to number 7, where we're going to be looking at parallel lines. What do you notice about these two lines in standard form that are parallel? They look the same on the left, right? 7x minus 2y, 7x minus 2y. But on the right side of the equation, the C, that's different, right? Because I've got to have a slope-intercept. I've got to have two different intercepts, y-intercepts, sorry. So let's convert line P to slope-intercept form. I'm going to subtract 7x from both sides. I'm left with negative 2y equals negative 7x plus 10. Divide everything by negative 2, and I'm left with y equals negative 7 divided by negative 2 is positive 7 over 2. X. 10 divided by negative 2 is negative 5. So I write minus 5. So there's the first line P in slope-intercept form. Line R, let's do this one. I'm going to subtract 7x from both sides. I'm left with negative 2y equals negative 7x plus 8. Everything gets divided by negative 2, and I'm left with y equals 7 over 2x minus 4. So as you can see, these lines have the same slope, 7 over 2, but look, they're different lines, they're parallel, so they're going to have different y-intercepts. Now let's look at number 8. Now these lines are going to be perpendicular. What do you notice about these lines? They look different, right? On the left side, the left side in standard form, that looks different. So let's solve for y in this first equation. All I have to do is subtract x from both sides, and I get y equals negative x plus 7. Let's do the same thing for line T. Notice here, when I subtract x from both sides, I'm not done because I'm left with negative y equals negative x plus 4. A lot of students like to write a 1 in front of that variable to know that, now that's how I can divide by negative 1, right? It's the same thing. It's a visual thing, and some students really like it. So I divide everything by negative 1. Well, that's how I undo this negative y, and I'm left with y equals, that's just 1, or negative 1 divided by negative 1, which is just positive 1. I don't have anything there. 4 divided by negative 1 is negative 4. So how are these lines perpendicular? They're only opposite. Well, remember 1 is just like 1 over 1. So if I have a slope of a line that's negative 1 over 1, and I flip it and take the opposite, it's just positive 1 over 1. Now let's look at number 9. This says convert lines E and G to slope-intercept form and graph. So the first thing we're going to do with line E is convert it to slope-intercept form. I'm going to subtract x from both sides. I'm left with negative 2y equals negative x plus 6. Divide everything by negative 2. And I'm left with y equals positive 1/2 x minus 3. I'm going to identify my slope as 1/2. Y-intercept is -3. I'm going to plot that -3 on my y-axis, and then my slope is rise 1, run 2, rise 1, run 2. And it looks like this. Go ahead and label it line E. And I would encourage you to pause the video and copy all of that down. Now let's look at line G. I'm going to solve for y. Subtract x from both sides. I'm left with -2y equals -x plus 14. Divide everything by -2. So I get y equals 1/2 x minus 7. I'm going to identify my slope as 1/2. My y-intercept is -7. So the first thing I'm going to do is what when I graph it? Graph that y-intercept. Put a dot at -7 on that y-axis. It's your y-intercept. Put a dot there. Then from there, rise 2, run 1, put a dot there. Rise 2, run 1, put a dot there. I'm sorry. I said that totally wrong. Rise 1, run 2. Rise 1, run 2. Looks like this. There's my y-intercept at -7, up 1 over 2, up 1 over 2. That's line G. Last example on this set of notes is number 10. We're going to convert lines I and J to slope-intercept form, and we're going to graph. Line I, if I solve for y, it looks like -2x, and I just get y equals -2x plus 5. That was easy. Identify the slope as -2. Y-intercept is 5. How do we graph it? From my origin, I go up 5 and put a dot there. Slope is negative, so I know it's going from upper left to lower right. Going down 2 over 1, down 2 over 1, down 2 over 1, and it looks like this. There's line I. Now let's look at line J. When I solve for y, it's a little more involved. I subtract x from both sides. And in this case, now I need to divide everything by -2. -1 divided by -2 is +1 over 2, x. 10 divided by -2 is -5. So my line and slope-intercept form is y equals 1/2 x minus 5. I'm going to identify the slope as 1/2. The y-intercept is -5. Now, how do I graph it? I'm going to graph my y-intercept first at -5, and then my slope is going to be rise 1, run 2, rise 1, run 2, rise 1, run 2. And it goes from lower left to upper right. And you can see these lines are perpendicular. These lines over here are parallel. Remember, parallel lines, slopes are the same. Perpendicular lines, slopes are opposite reciprocals of one another. And that concludes your day 1 notes over writing equations of parallel and perpendicular lines. It's going to be a little more involved in your next lesson, but I hope these notes were helpful.